Hi, welcome to Concepts of Science, and my name is Rajesh, and I would like to discuss with you today the concepts of physics. Because the why to discuss the concept? Because if you do not know the concept, then you will not be able to understand the subject properly. And this is the reason that most of the people, most of the student, they do not understand the concepts of physics or concepts of chemistry or concepts of biology. So when you do not understand the concept, you cannot understand the subject, and then that subject makes you to be fearful. So I hope you have enjoyed 1 minute intro before starting this video, so that this is saying about how we are able to help you in clearing your concept. So let's discuss about the things. My purpose is to help you in getting success in various competitive exams, whether it is medical or engineering entrance. You need to achieve the success, and in order to achieve the success, you need to give the correct answer. So without knowing the concept, you cannot solve numericals in physics. You cannot answer any multiple choice question, you know. So this is if you like my classes, then you need to achieve the success, and in order to achieve the success, you need to give the correct answer. So without knowing the concept, you cannot solve numericals in physics. You cannot answer any multiple choice question, you know. So this is if you like my classes, then please don't forget to click the like button, and don't forget to subscribe my channel so that you will be updated about my new postings, and I would do my best to cover whole syllabus of physics as soon as possible. I know this is the time that you are preparing for exams, and even if you are not preparing for exam, just make sure that you are ready for the exam when the time comes. So this is going to be helpful in many ways. So in physics, as far as physics is concerned, this is very interesting subject, and the only thing that I would like to tell you from my side, that if you listen to my video attentively, then at the end of the video you will be someone different in the sense that first you will know many things, many concepts. Now, so let's start, go from there. Okay, so today topic that we are going to discuss is fundamentals of units and dimensions. So we are going to discuss, let me explain first what are units. What do you understand by unit? So in everyday life, we measure things. We constantly keep measuring things around us in a certain way. But why? Why do we do that? We do that because when we measure certain thing in a certain way, then our approach to count them in numbers. And it is very interesting to for you to know that whatever measurement we make, we end up in a number. Okay, and the measurement involves comparison with a chosen standard or unit of a similar kind. Now, let me go to a little bit more detail. First, I would like to tell you that when we are measuring something, so the measurement of a physical quantity is essential to express two things. Number one, the standard or the unit in which the quantity is being measured. And number two, the number of times the quantity contains that unit. Okay, so I think be patient and let me give you an example. Let's say a dozen is a standard or a unit. Okay, now in which we count, let's say, eggs. So we count eggs in a dozen, right? Therefore, we must know how many times an egg is contained or counted in 1 dozen. Now you know that in 1 dozen there is 12, right? 12 eggs. So the answer is 12, right? Correct. So we know now that an unit that is called dozen contains a count of 12 of a particular thing. In our case, it was eggs. Okay, so let's what is fundamental physical quantity, because we are going to discuss eventually the fundamental units. Okay, so before we discuss the fundamental units, we need to know the physical quantities. So what are fundamental physical quantities? So by definition, fundamental physical quantities are those physical quantities which do not depend upon any other quantity. And here I would like to tell you that there are 3 fundamental physical quantities that don't depend on anything: mass, length, and time. So mass, length, and time. So this is from the historical, very ancient time. It is been understood that mass, length, and time do not depend on anything. We will discuss later what are other fundamental physical quantities in modern days. So for now, this is 3. And let's move on. So now you understood what is fundamental physical quantity. Fundamental physical quantities are those physical quantities which do not depend on any other quantity. Okay. Next point is what are the fundamental units? Fundamental units are those units in which fundamental physical quantities are being measured. So fundamental physical quantities are mass, length, and time. The units of mass is going to be kilogram, right? So kilogram is going to be fundamental unit. Length we can measure in meter, so meter is going to be the fundamental unit. And time we measure in second, so this is going to be fundamental unit of time, the second. Now, what do you mean by what kind of different physical quantities we have in physics? So in physics we have 2 kind of physical quantities. One are fundamental, they do not depend on anything, and the second kind of physical quantities are the derived physical quantities, and of course they are being measured in derived units. So I would like to tell you the definition of derived physical quantities. Derived physical quantities are those physical quantities which depend on fundamental physical quantities, right? So don't worry, there is nothing to get confused. Fundamental physical quantities, they do not depend on anything: mass, length, time. And now there are certain different physical quantities that depend on mass, length, time. I wanted to say that. For example, this is the velocity. So velocity, force, acceleration, these are the derived physical quantities. They depend on fundamental physical quantities. So what are the derived units? Derived units are the units in which derived physical quantities are expressed. Okay, so let's discuss about why velocity is a derived physical quantity and the unit of velocity is a derived unit. Why? This is the question. So I would like to explain this thing this way. Velocity is defined as the rate of displacement per unit time. What is velocity? Velocity is the rate of displacement per unit time. So you can see the forthcoming slide will show you this thing. So you will be able to make a note from there. You can pause the video there and you can make a note. So, and displacement is measured in length. So velocity is displacement upon time, and displacement is measured in length and time is measured in second. So both the displacement and the time are fundamental physical quantities, right? Yes. By definition, velocity is displacement upon time. So without knowing these two fundamental physical quantities, that is displacement and time, velocity cannot be derived. Therefore, we call velocity is a derived physical quantity. Is that clear now? So this was the concept. And because its dependency, because velocity is dependent on fundamental physical quantities, their unit, that is meter per second, is also derived unit. If you do not have meter, if you do not have second, you cannot get the unit of velocity, right? So derived physical quantity, you understood, and the unit in which derived physical quantities are expressed, it is called derived units. Now, this is a time for you to make a note. I would like to give you 5 different derived physical quantities, and you have to find their units. So what are they? Write down. Number 1, this is surface tension. Number 2, acceleration. Number 3, work. Number 4, moment of inertia. And number 5, force. So you have to find the unit, in which unit, like velocity is expressed in meter per second. So how surface tension will be expressed? How surface tension will be measured? In which unit? How acceleration will be measured? In which unit? What is the unit of work? What is the unit of moment of inertia? And what is the unit of force? So why did I give you all these 5? Because I want you to experience what happens when you start finding the unit. So you will see that if you are beginner in physics, then you will have a problem. You don't know how to find the units of these derived physical quantities. So for that thing, I would like to suggest you one thing. Whatever problem is happening in your head and whatever confusion is coming in your head, make a note on the paper, okay? And yes, you can also join me directly in online classes. So if you want to join me on online classes, my number is mentioned there in the intro of the video, and my email is also there in the intro of my video, so you can write directly to me on my email, and you can book for the classes. But for now, I will give you one suggestion, and the suggestion is that make sure that you know the definition of these 5 derived physical quantities. If you know the definition, then you must have to know how to measure them. So if you know the definition, if you know how to measure them, then you will be able to understand what are their units. Okay, you can derive their units, because this we are all talking about derived units. So units are to be derived here. Okay, now let's move on to the next segment of this topic, unit and dimension. We have 4 kind of systems of unit. 4 kind of systems of unit. Let's discuss about CGS. This is centimeter gram second. So in this system, the unit of length is centimeter, the unit of mass is gram, and the unit of time is second. The second system is FPS system, foot pound second system. In this system, the unit of length is foot, the unit of mass is pound, and the unit of time is second. The third system is MKS system. This is meter kilogram second system. In this system, the unit of length is meter, the unit of mass is kilogram, and the unit of time is second. Perfect. Now, when you will see my slides coming up, you will see some interesting facts there. Okay, so interesting facts, you make note from there. These are interesting facts just to give you some spark in your head so that you should know that how our world is there, and whatever we know, how much we know, and what are the interesting facts behind that. The number 4 system of unit is SI unit system, Sistema Internacional. So in this system, there are 7 fundamental physical quantities. We were discussing now 3 fundamental physical quantities, mass, length, and time. Now you have to know 4 more. And these 4 more fundamental physical quantities are included only in Sistema Internacional, that is SI unit system. So there is number 1, mass. The name is physical quantity is mass, and we measure mass in kilogram, and the symbol is kg. The second is length. The measurement we make in meter, and the symbol is m. The third one is time. We measure time in seconds. The symbol is s. The fourth one is temperature. Temperature is fundamental physical quantity that is measured in Kelvin. Symbol is K. And the fifth one is luminous intensity. That is candela. We measure luminous intensity in candela. Symbol is CD. The sixth one is electric current. Fundamental physical quantity, electric current. And we measure electric current in ampere. And the symbol is A, capital A. And the seventh and the last one is amount of substance. So amount of substance is being measured in mole. So many people have concept is not clear about the mole. We would discuss this later, probably in physical chemistry, or maybe in this topic I will pick up some time, and we will discuss about the mole as well. The symbol is MOL dot. And in the SI system, out of these 7 fundamental physical quantities, we have 2 supplementary units. It means 2 supplementary fundamental physical quantities, that is plane angle and solid angle. So plane angle is measured in radian, and the symbol is RAD dot, and solid angle is measured in steradian, that is the symbol is SR. Now the question is, what do you mean by solid angle? This is a very simple thing. Let me demonstrate to you. So the plane angle means, you see here, this is when we make on a page like this, this is the plane angle. And when we talk about a cone, so this cone, you see here, at the end, at the center there, they are making angle. So this kind of angle is known solid angle. So it is measured in steradian, and plane angle that you make like a here, like a, you see, this is the angle here, made angle. This angle is the plane angle. So 2-dimensional angle is plane angle, and 3-dimensional angle is solid angle. So 2-dimensional angle is measured in radian, and 3-dimensional angle is measured in steradian. Okay, that is enough for SI unit, MKS, FPS, and CGS.